So the first criterion is safety. No coincidence that this is really the #1 criteria, because we cannot afford to develop a process which on large scales is failing, and that there is, for example, an explosion where potentially people can die, and that also there can be a complete disruption of the commercial supply chain, where also it could mean that patients do not longer have access to the medicine at a certain moment. There are at least two categories of hazards. First one is the thermal and reactive hazards. Has to do with the property of the reaction itself. To avoid that there is a thermal runaway where the reaction is mixture is getting to a temperature above which it's not longer stable. Second, on large scale, if there is a reaction where gas is evolving, it's completely different than on lab scale. If you are doing, for example, a bug deprotection on small scale, you do not worry about the fact that you are generating isobutene. But on large scale, we are talking about potentially significant volumes of isobutene during a bug deprotection. That's just one example, but a demethylation with HBr, where you are generating methyl bromide, you might not consider that in a lab environment, but on large scale it's an important attention point. Certainly potential explosives, to be careful when handling these on large scale. Some of the reagents we are using are really corrosive. So on the long term we have to make sure that we can keep our equipment in a decent state. So we have to select the right equipment and protect it as much as possible. And also pyrophoric material, pyrophoric reagents need special attention for example, for storage, but also for dosing, for neutralization after the reaction. Second category are the toxic hazards, where the general principle is that first of all we try to avoid them by not using them, by using other reagents which are less toxic. If there is no real alternative, we try to reduce them, reduce the amount, and after that we try to control that on the one hand by containment and by engineering the process and the equipment as such that it's in a closed environment, and if really needing, also protecting the workers who has to handle these reagents on large scale. And there is a difference between acute and chronic toxicity, as you are aware of. For some of them you will observe it immediately if there is something wrong. For others you only see the effects after a long time. General principle is if you don't scale, if you cannot scale it safely, don't scale it at all. A little bit of foam in the lab, can be funny, not a problem, but some foaming on large scale, uncontrolled, and that can be potentially very toxic, what's coming out of the reactor there. I'm sure you agree with me that you don't want to see that on